This is a double replacement reaction, and I can tell because it's two ionic compounds, metal and nonmetal, metal, nonmetal. They're both dissolved in water, and so what's going to happen is that the positive part of one will go with the negative part of the other. To do this, though, I need to figure out the charges first so that when I write the formulas, I can figure out the subscripts. So using the periodic table, I can tell that chlorine is -1. And then copper is in the middle of the periodic table, so it's hard to know. You can figure it out from the chlorine, though. I have a -2 charge here, so this must be a +2 copper. On the symbols to memorize on the upper right, there's some common metal ions, and you can see that copper can either be +1 or +2, so that's why I have to figure it out. On this one, sodium is in the first column on the periodic table, that's +1. Sulfur is in the -2 column. Now I'm ready to bring these over. And remember, what we're doing is that the positive part of one, which is in the front, goes with the negative part of the other, which is in the back. So copper will go with sulfur, and their charges don't change. The charges remain the same on double replacement reactions. And I can tell that that is a good formula for copper sulfide. Now I'm going to go with the sodium. The positive one always goes in front. It goes with the chloride. And its charges are +1 and -1. So again, a good formula without having to do any work. Balance this, and just start with something you see that's not balanced. I see chlorine is not balanced. There are 2 chlorines in the reactants and only 1 there, so I'll put a 2 there. That 2 just affected sodium, so I'll do sodium next. There are 2 sodiums here and 2 there, so sodium's balanced. 1 sulfur, 1 sulfur, 1 copper, 1 copper. Everything else is balanced. Now I need to figure out the states of these, the states of matter, if they're solid or whatever. And the way that I do this is that, well, for one thing, I know that list of 6 soluble ions. There are 6 ions that only form water-soluble compounds. And if something is soluble, this is an aqueous environment, there's water there. If something is water-soluble, then it will be AQ, aqueous. And sodium is on that list of the 6 soluble ions, so I know it has to be AQ. Okay. I don't have a simple rule. I don't have to look up copper sulfide, but I have another hint, and that is that if a reaction occurs, I must have a solid form which is a precipitate, or a covalent compound form. Okay, and in ours, the only covalent compound we're going to see is water. This one doesn't. These are both ionic compounds. So I know there must be a precipitate. And so since that one's aqueous, I know this one has to be the precipitate. And remember that that means it's solid. And I'll just mark it PPT. Now we're going to do the net ionic equation. And we kind of do this a shortcut way. And what I do is I say, well, look at you would look at either the covalent compound or the precipitate. And we have our solid here formed. And what you do is you write the reaction that it takes to make that. So in other words, I want the product of my net ionic equation to be this. And then I figure out what ions are coming together to make that. I have 1 copper ion, and it's going to be AQ because it was there. And then I have 1 sulfide ion. And make sure it's balanced, and it is. So that is my net ionic equation.